All right, slide 9 of 14. Find all zeros by guessing or graphing the two real zeros of x squared plus no x cubed, notice that's in parentheses, minus 14x squared plus no x plus 45. Notice I use the quotes there. You need those zeros for synthetic division, and then synthetically dividing them out to form a quadratic that you can utilize to find the imaginary solutions. So let's do what the hint says. You're not going to have time on test day to guess zeros. We're going to graph that function. She was x to the fourth minus 14x to the second. You can put in the zeros if you want. Don't you dare do something stupid like put in the quotes. God love y'all. You'll do it. Do a zoom 6. This thing probably factors. It does. Anyways, we should have something at probably 3 and yeah. There's one right here at positive 3 and there's another one right here at negative 3. If I'm not sure about where they are, I can put a 0 into y2. And I can hit second trace 5 for intersect. And I'm only going to go after the good looking ones. That is not a good looking 0. But this one is. Get close, press enter 3 times. There she is. 3, and this one over here is negative 3. All right, so here's what I've learned. From the graph, x equals 3 and negative 3. And I'm going to synthetically divide those out. There is 1x to the fourth. There are no x cubes. There are negative 14x squareds. There are no x's, and there's a 45. I made my synthetic division a little too big. You hadn't done synthetic division since before Christmas. We drop, we multiply, and we add. We drop the 1, and I guess I'll start with the 3 first. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 14 plus 9 is negative 5. 3 times negative 5 is negative 15. 0 plus negative 15 is negative 15. 3 times negative 15 is negative 45, and I got a suspected 0. Remember, remainder. I'm going to drop down and continue the process. We're going to use a negative 3 this time. We drop. Negative 3 times 1 is negative 3. We add. We multiply. We add. We multiply, and we add. And again, remainder. Preceded by the remainder is a constant, an x, and an x squared. This is x squared minus 5, and it is equal to a 0, because there are still 2 zeros left. We reduce to a quadratic because we can solve quadratics. Now, you can do a quadratic, and it says you can utilize, you can do, you cannot. I taught your class how to factor these. Generally speaking, though, you move to the right, and you just take square roots. Opposite of squaring is square rooting, so plus or minus root 5. Now, I'm saying that according to doing math by hand, the answer is plus or minus root 5. Root 5 is going to be a little over 2, obviously. It's about 2.236. Second trace 5 for intersect. And remember those funny zeros I didn't use? See, I don't want those decimal answers. But had I picked one of these things, there she is, 2.236. Now, if you happen to know that that's square root of 5, awesome. I don't expect anybody does. All right, moving on to 17. 17 is find an inverse. And inverse functions are pretty easy to do. All you do is you swap x and y, and then you resolve for y. And finally, you replace y with the inverse of f of x, written f to the negative first power of x. So I'm going to do my 3 rules here. That 3x becomes a 3y. 6y becomes a 6x, still equal to 12. I am going to subtract 6x from both sides, and I'm going to divide by 3. And finally, I'm going to make that the inverse of f of x. And that's it. You move that over where you can see it better. Cha-ching. That's how it's done. It's not necessarily hard. It's not. More inverses. 18 is the opposite of the square root, and they have this little disclaimer here where it's valid. The reason they have this disclaimer is because the square root only works if the inside is greater than or equal to 0. So that's why there's this little domain restriction. Anyways, let's do our steps here. These don't take too long. X would be the square root of 3y plus a 2. We will counteract the square root with a square. Squares cancel out the square roots. X squared is 3y plus 2. We'll shift that 2 on over. X squared minus 2 is 3y. And then we'll divide by 3. So here is my inverse. That's how long it takes, kids. It don't take that long to do it. B is the hardest inverse on this piece of paper because it is a fraction. So most kids are going to be looking at B saying, I don't know what to do because it's got a fraction. Why is this here? Because remember, this is here. If you plug in a 4/5, you'd have a 0. That's why that's there. You can't divide by 0. That's why they put it there. We'll do our steps. Y becomes X. X becomes Y. And what we're going to do is we're going to clear the fraction. We're going to multiply both sides by 4y minus 5. Cancellation on the right. Going to invoke the distributive property. 4yx minus 5x equals 3y plus 3. And what we're doing here is we're solving for y. All y's on one side. So this guy is going to come over here and everything else on the left or on the right. 4yx minus 3y equals 5x plus 3. Now what we're going to do is we're going to factor y times 4x minus 3 equals 5x plus 3. And now we're going to divide out 4x minus 3. So this will actually do the solving for y, so I'm just going to save paper and write that the inverse of f of x is 5x plus 3 over 4x minus 3. She's done. It was a walk in the park, man. A walk in the park. Moving on to example C. Y equals x minus 3 cubed plus 4. I'm not sure why they have the domain restriction on that one. It doesn't need one. That shouldn't be there. That's a cubic function. All cube roots have inverses. So I'll go back and edit that in a little bit. And this is just the same old stuff over and over and over. I don't know if you're bored of this yet or not. You're probably bored for different reasons than I am. I'm bored because I view this as easy. You are bored because of your lack of interest. Anyways, we're going to shift that 4 on over. X minus 4 is y minus 3 all cubed. We're going to counteract a q with a cubic root. And then we're going to add 3. Notice I'm adding the 3 outside of the radical. and she is done. That is how you find the inverse of that function. Whew. 4 slides to go. The graphing section. It says use y equals a square roots of x minus h plus k, a cubic roots of x minus h, y equals a times x minus h squared plus k, and y equals a times x minus h cubed plus k, where hk is the center. After finding the center, make a small table to plot 2 other points. I don't know that I'm actually going to make the table. Main thing is I remember the mom functions. Here, the mom function is y equals the cubic root of x. I know that's small, but that's a 3 there. It's supposed to be anyways. And the cubic root of x has 3 key points. I know you're as excited about this as all my classes ever have been, but that's what mom looks like. All right. We're going to go right 2. We're going to go up 4, and this is our slope. This is how I have done these forever. And I'll just do it down here and clear the page. Right 2, up 4, notice my slope is 2. I'm going to rise 2 and run 1. About there. And I'm going to fall 2 and run 1. And then I'm going to redraw mom. So that's number 19. Not too hard. Number 20, we've got a mom function of y equals x cubed. It looks a lot like the one I just did, except it's a vertical snake. And what do we have here? We have a left 3, we have a down 2, and then we have this kind of slope. Kind of slope. I'm writing slope, but it's kind of slope of -2. Left 3, down 2, and the slope is -2. Now, the thing's going to be upside down. It's going to start high and end low. It's going to start up here and end down here. We're going to rise 2 and run back 1, and we're going to fall 2 and run right 1. And there she is. And the last little bit of this graphing section is a square root function. The mom function is y equals root x. 2 key points are 0, 0, 1, 1. Draw an arm. That's mom. All right. Here we have a left 1 and an up 3 transformation. I went left 1 because I do opposite of whatever's inside. I went up 3 because I always trust what's on the outside. And your slope is the understood 1. So it's going to have its center right there. It's going to rise 1, run 1, and you're going to draw an arm. And that's how you do 21. These are all super easy problems. I think they're easy. I wish I could get y'all to agree with me. Here we have simplification. I don't know about you, but I'm having a hard time seeing what that exponent is there. So let me pull up the original document. Sometimes when I copy out of documents, it's hard for me to read them. Still kind of hard to read. That or I'm just old. I'm almost certain that's a 3. It is. It's a 3. So that won't be too bad. I don't know if I can make it legible here. Still looks pretty messed up, doesn't it? Yes, it does. A couple of these do. Hopefully when it's printed out for you, it won't look that bad. The idea is to divide the power by the root the remainder stays inside. Now, a couple of these we're going to have to do some work with. Like, you're going to have to play with 500. I happen to know that 500 is 125 times 4. And that's what I'm going to do. I'm going to break this into a whole bunch of different things in the hopes that maybe you understand this. But I've got the cubed root of 125 times 4. Here I have the cubed root of x to the 7th. And here I have the cubic root y to the 6th times the cubic root of z cubed. That's expanding everything. The cubic root of 125 is 5. So I have 5 cubic roots of 4 left over. 3 enters 7 twice, so times x squared. Cubic root of x left. 3 enters 7 twice, remainder is 1. Times 3 is 6, add 1 is 7. 3 enters 6 twice, remainder of 0. 3 enters 3 once, remainder of 1, remainder of 0, so nothing inside. And then I'm going to put all my radicals and everything together. I have 5x squared y squared z, 5x squared y squared z, cubic roots 4x. Oh, simplification. All right, that's 23. 24 is going to be next. I can actually read that one. 24, you can only add or subtract radicals if they contain the same thing. So we're going to do some simplification. We have 3 times the 4th root of 32 x to the 6th. So let me pay attention to 4th root of 32. The 4th root of 32 is the same as the 4th root of 2 times 16, and the 4th root of 16 is 2. All right. 4 enters 6 one time, so there's going to be an x outside. We've already got a 3. Now I've introduced a 2. 4 enters 6 once. We're going to introduce the x. Let me clear that out. Doesn't look quite right. 4th roots, there's a 2 inside, and 4 entered 6 once with a remainder of 2. Minus because there's a minus. This is now a doable problem. This becomes 6x, 4th roots of 2x squared, minus 3x, 4th roots of 2x squared. 6x minus 3x is 3x. And there's 24. 25 is next. I've got to go back to the original document to see what this thing actually looks like because I can't read it. That is x to the 1/3 over x to the 3/4 raised to the negative third power. There's a couple ways of doing this, but what I usually do is I distribute the outer exponents first. When you talk about x to the 1/3 times a negative 3, be over x to the 3/4 times a negative 3, the numerator becomes x to the negative 1st, and the denominator becomes x to the negative 9/4. Now, I have a rule that says x to the negative n is 1 over x to the n. I'm going to shift things around. I'll have x to the 9/4 up top, x to the 1st down low. Now I have the rule x to the a over x to the b is x to the a minus b. So this becomes x to the 9/4 minus 1, which is 4/4, which is x to the 5/4. Final answer. Ta-da! It's not magic. It's knowing rules and properties. That's all math is. Rules and properties, forms and function. And, oh, there's just more. I'm going to stop here because I actually have to start doing some grading.